Hi, this is Mrs. Robertson, and again today we are making this video during 6th period in my Math 7 cluster class. Say hi, kids. Hi. Thank you. Now, we're going to go and do the answers for those of students that aren't able to be here, or if you just want to review to make sure you know how to do everything before the test on Thursday. Okay, in the first section, determine whether each event is impossible, unlikely, even chance, likely, or certain. Okay, on the first problem, rolling an even number on a number cube is even chance. It's a 50-50. Rolling a 5 on a number cube, it's 1 out of 6. It is unlikely. Rolling a number greater than 2 on a number cube, that's 4/6. It is likely. Rolling a number less than 1 on a number cube, 0. It is impossible. If two events are complementary, when added together, they must equal one whole. Now, it says events A and B are complementary. So the complement to 64/100ths, 36/100ths. Now, another way to write a complement to an event, sometimes they will put like a little apostrophe. That would mean it's the complement to A, okay? But here they said B is the complement to A. Question?
Does it have to equal 1?
Yes, in order to be a complement, it has to equal one whole. 3/7 complement would be 4/7 because 4/7 plus 3/7 is 7/7, which is a whole. The complement to 22% is 78% because 22% plus 78% equals 100%. Now, find the probability for each event. Write each as a fraction, a decimal, and a percent. We're using a number cube in the first 3 problems here. The probability of getting a 4 is 1/6. The decimal, 16/100ths with the 6 repeating. So your percent would be 16.6 repeating percent, or you could round it to the nearest whole percent if it asked. That would be 17%. The probability of rolling a prime number. Now, kids, 1 is not prime. It has only one factor. Prime numbers have exactly 2. That could be a question on the test. That's a tricky one because you will forget what a prime number is. So a prime number on a number cube, the prime numbers are 2, 3, and 5, not 1. Okay? So there are 3 of them. And that's the decimal 5/10, which is 50%. A number less than 3, there are 2 of them. The decimal for 1/3 is 3/10 repeating, and that will be 33 1/3%, or 33.3 repeating percent, or if you rounded it to the nearest percent, 33%. Okay? In the next section, we are looking at the spinner. The probability of spinning a vowel, or the spinner landing on a vowel. The vowels are A, E, I, O, U, and sometimes Y. Well, on the spinner, your vowels are O and E. You have 3 of them, 3 out of 8. Your decimal, 375 thousandths. Your percent, 37.5, Are there any questions? This is what's going to be on your test, so make sure you know how to do it. Probability of landing on an N. There are two N's. 2 8 equals 1 4. 5%. The probability of not landing on an A? Well, there are no A's. So it's 8 out of 8, which equals 1. On page, let's go to the next page. Here you have to make a tree diagram for flipping a coin or tails. When you roll the dice, you have 6 possibilities. You could have a 1, a 2, a 3, 4, 2, tails 3, tails 4, tails 5, tails 6. Now it wants the sample space. So for the sample space, it's heads 1, heads 2, heads 3, heads 4, heads 5, heads 6. Then we have tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. That is your sample. Equals 12. How do you get that? 2 times 6 equals 12. The fundamental counting principle. We're not going to do the sample space. So let's start off with the tree diagram, and you have 3 shirts. Shirt 1, then you have shorts, 2 pairs. Shorts 1, shorts 2, shorts 1, shorts 2, shorts 1, shorts 2. And I wasn't going to take the time out to write those full words out. Then the last thing, you have 2 pairs of shoes for each shorts. Shoe 1, shoe 2, shoe 1, shoe 2, shoe 2, shoe 1, shoe 2, shoe 1, shoe 2. But we are going to use our counting principle to figure out the outcomes. Our outcomes are 3 times 2 times 2, and that equals 12. It's a little more challenging, and I want to go over a few things with you. It's all about reading carefully. You roll a pair of dice. A pair means you're going to roll 2 dice, okay? How many outcomes are there on each dice? Q? 6. So you're going to roll a dice and a dice. Yes, Caden. 36. Do you see how we got that? Okay, put a star by 16. A company puts a code on each different product they sell. The code is made up of 3 numbers, number 1, 2, 3, and 2 letters. How many different codes are possible? So you have 5 entries in this code. How many different codes are possible? Well, how many digits are available for each number choice? How many digits do we have? No, digits, numbers. Yes. No. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have, or 9. You have 10 numbers. 0, okay, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That comes up to 10. So on each one of these numbers, you have a choice of 10 times a choice of 10 times a choice of 10. It didn't say you couldn't repeat the numbers. When you can't repeat the numbers, then you have to, take it times 9 and times 8 because you wouldn't be allowed to repeat a number. Now we have 2 letters. How many letter choices are there in the alphabet?
26.
So you have 2 letters times 26 times 26. So when you multiply those together, you are going to get 67,000. Ooh, no, it's 676,000. 676,000. 10 times 10 is 100, times 10 is 1,000, and 26 times 26 is 676, times 1,000 is 676,000. Any questions on that? That's how many possibilities there are. Now let's go to number 17. You have 4 different keys and 5 different marbles. How many outcomes are possible? Now this one's a simple one. It's just 4 times 5. Okay. In number 18, we have digits and letters again. You choose 5 digits. 1, 2, 3, 4, 5. And how many digit choices are there? 10 on each one. And 2 letters. How many outcomes are possible on this one? 2, 3. We're going to add, you need to have, it'll be 67,600,000. Any questions on that? Okay, Caitlin finds we're going on to the predictions now. Caitlin finds the experimental probability of her making a 3-point shot is 30%. Out of 500 3-point shots, about how many could she predict she would make? You take 30% times 500, or 500 times 0.3. 150. Any questions? Number 20. You roll a number cube 15 times. How many times do you expect to roll a number less than 6? A number less than 6 is going to happen 5/6 of the time. So 5/6 times 15. Gently pick it up, put a 1 underneath it. I will simplify before I multiply. 3 divided, you'll have 25 over 2, which equals 12.5. So on this one, you could say 12 or 13. An exact answer, okay? Use the spinner below to answer the following questions in 20 spins. About how often can you expect to get a number that has a are? Well, these are numbers you multiply together to get a 6. 1 times 6, 2 times 3. Are there any ways you can multiply to get 6 that are whole numbers? No. So how many factors are there? 1, 2, 3, 4. So it's 4/6 times 20. 2 goes into 6 3 times. 2 goes into 20 10. You end up 13 and a third. So you could do 13 and a third, 13. If you probably put 14, I would count that right because it has the word about. Okay. In number 22, in 150 spins, about how often can you expect to get a number less than 6? Less than 6, that's 5 6 times 150 over 1. Well, 6 will go into 6 once, and 6 will go into that 25 times. 5 times 25, 125 over. Okay, now let's go to the last page. And it's about 50 times, and the results are shown in the graph below. That is your experiment. Okay, these are the results right there of a number cube. What is the experimental probability of rolling a 5? On this one, it looks like it's 5/50, which means 1/10 of the time. Now, what is the theoretical probability of rolling a 5? If you had a number cube, what's the probability of rolling a 5 on a number cube? 1 out of what? 6. Do you see what the theoretical probability is? What is the experimental probability of not rolling a 1? So, not rolling a 1, you're going to do 8 plus 6 plus 9 plus 5 over 50. And you get 40 over 50, which equals 4/5 or 80%. Okay? 4/5 or 80%. Then it says theoretically, it can 5 out of 6 times it's not going to be on a 1. Any questions on the difference between theoretical and experimental? All right, then what do I want you to do? I want you to work on your experiments. You have this paper. It's going to be worth 90 points. I will be collecting it Friday. I'll just tell you, I'll take the grade on it on Friday. You have till Friday. Is Mastery Connect when you put it in. So you'll have time after the paper test to do this. This is how you're grading it. Each experiment is 10 points. Experiment 1. Now, the one in the Google Classroom says 30. So on this paper, this was used a couple years ago when we had plenty of time and weren't doing it during iLearn. So whenever it says 50, you can change it to 30. Let's see. Here's one. Experiment number 5. You can change it to 30. Experiment 6. You can change that to 30 times. And as you can tell, each one know what to do. Okay, thank you for keeping an eye on things. This one, you can do it 30 times. Flipping a coin 30 times. Now, as you all know, when you go into my Google Classroom, you click on the experiment document. This is the recording sheet, but you click on the things and it will roll the dice for you. It will change your M&M colors for you. You just click on the device and it does it for you. You don't need dice or cards or M&Ms. All of that is built into the experiment problems there. So there you go. Have this done by Friday. You will turn it in. 10 points are for your behavior and effort. That's what you will be getting your the 10 points, because there are 8 experiments plus 10 behavior focus points equals 90. Have a good day.